Hello guys, my first video in 2024. Wish you a happy new year, all the best in this new one. And okay, let's start building something. A lot of people ask me about Behringer power supplies. First of all, this kind of mixers, they are using a AC output power supply. So normally everything should be DC, I mean direct current. But Behringer, and not only Behringer, it's Phonic and so many other small format mixers, they are using differential or 2 times AC voltage output. And if we take a look here, something like that, you see, these are MX602, UB5, and so on, UB802, XENYX series, 502, 802, 1002, and so many other models, mixers from Behringer. They are using the same power supply with this kind of socket, kind of strange and not so reliable. So on my mixer I had to replace the socket. I have a video about that right there. This is for Phonic, and the output is 14.2 volts with 500 milliamps AC, alternative current. This is a Behringer 802 XENYX. And if we take a look closely here, okay, we can see on this one, but I can tell you it's 18 volts, 18.5 volts with 150 milliamps. There are so many models on the market, so my experience is that 200 milliamps is more than enough for any Behringer details. Okay, let's see this guy. Yeah, 18.5 volts with 250 milliamps. About this? No, that's a switching adapter. You see, for having AC output, you can't use a switching power supply, SMPS, so it have to be a transformer, classic, somehow. Can we see closer? Any details? Right. Look at this guy. 2 times 17.5 at 420. That's for XENYX 802. So you see, there are a lot of alternatives. 18.5, 17.5, and so on. All I can say that inside Behringer, so that's a differential linear power supply, so I recall it works around 15 volts or something. Anyway, so we can have any kind of output between 15 volts to 18 volts, even 19 volts AC. That's not so critical, but not more than 18.5 or 19 volts maximum, and minimum, let me say, 14.5, 15 volts AC. Okay, now let me show you how is this transformer looking like. So you see, we have that's the core, the magnetic core. So here we have the primary winding, which goes to 120 or 230 volts, depends on the country. The point is, with the secondary, we should have a coil like this. First of all, a middle, which will be 0, or better said, ground. Okay, now we have a coil here supplying 18 volts AC, and the other one here supplying the other arm of 18 volts AC. So in fact we have 2 times 18 volts AC. All right. In case you already have a transformer with anything between 15 to 18, 19 volts or something, with a single coil or a single voltage in secondary, let's say 18 volts AC here, all we have to do is to open the transformer and add another winding for exactly the same plus minus half volt. It's not so important. And then all we have to do is to tie these guys together. That will be the ground. And here we'll have 18 volts and another 18 volts. So for a proper transformer, if you measure from here to here, when the phases are okay, we should have around 35-36 volts AC. If they are not in good phasation, it will be 0. It's very simple. So let's do something practical now. You see, guys, in between my stuffs, I found a very old transformer, you know, ringing bell. So this have more than, I think it's 50 years. Okay, it's from 1969, people. But I'm not worried about, because these stuffs are working for a lifetime. They are built to be on for tens of years. I can tell you, it's really well done. Proper winding. Look there. Shouldn't be any problem of having this transformer rewind for our purpose. This one should supply around 0.5 amps, and this is really good. Before having this out from the case, let's measure something. So this is the primer, the input winding here. We should have around hundreds of ohms. So you need to check this first. You see why I'm talking about adapting a transformer to be a power supply, because it's already industrial done. All we have to do is to change the secondary. So what we got here, told you we have like 936 ohms. This is so great. Here I have another transformer, industrial, and we have 540 ohms. Evidently, if we have more winding and more resistance in here, that means it's very well suited for supplying power for a long period of time. Evidently 900 here, it's better than 500 there. But that will work also, no problem. What about the secondary? We should have like tens of ohms. Okay, 5 ohm here, 6 ohm here. All right, we don't care about that anymore. Let's plug this in. You see, be real careful, because we are working here with live power. Voila, stay there, don't move. Power on. Let's see about the voltages here. AC, of course. We should have 8 volts or something maximum. 12.8, 4.8, 7.8. Let's write these numbers down. We need something to draw some power, you know. Then we can precisely have an idea about the voltages. Voila. You see the bulb, it's lighting. And now we can measure properly. Let's see. 10.8 volts. So here we have 10.8 volts AC. Oh, this is RMS. You see? To be sure about something, let me have a test with amps. Look, there is giving in short 1.5 amps or something, so it's strong enough. It's really strong. Okay? You see, sometimes the old guys are doing such a good job instead of true RMS and blah blah blah. Okay, there we go. Power off. So remember, we have 10.8 volts under load. Now all I have to do is to take out the transformer and open up the secondary. Okay, there we go. So it's out. Primary, what is saying here? 5 and 8 volts here. All right, we should have all this core stuff out, and that's very interesting. Usually they are E and I format, but this is even better because it's so easy to be changed and rewinded and stuff like that. You see, it's really nice. Special kind of iron core. It's not ordinary metal. It has some magnetic properties for better transfer. You see it's alternating, one with the open here and the other one 180 degrees the other way. So like I said, any format will do the job. By chance I have this kind of easy stuff. And thus everything gets out. You see, if you don't have a winding machine, no panic. There are not so many turns, so it can be done by hand without problem. They even supply the number of turns, 266 with 0.35. That's for 8 volts. But you saw that we have like 10 volts. So 266. I don't think we have enough space for fitting 3 times more wire than this. Alright, so if you don't have a machine like this, don't panic, you can do it by hand, very nice and easy. I'll use this guy because it's easy for me to demonstrate these things. Okay, we're gonna use something like this for, let's say 02 for the secondary, but now I have to get rid of these guys here. So I'll just rewind. I want to do like that because I want to count in a proper way the number of, you know what's funny, this is like 50 years old wire, but look here, it's still alive and looking perfect, and I bet it's better than what you can find today in all these transformers. The first connector or interconnection, how you can call this, reprise or prise. 100. I think I lost 1 or 2. I don't want to use this first winding because I don't have enough place to fit the second one, so it's better to rewind everything from zero, from scratch. Yeah, 265. Okay, very close. Well, I'll keep this wire for some other projects, and we'll use this kind of 0.2 millimeter for the secondary. And all we have to do now is to find out how many numbers turns we need. So we have 266 going to 10 volts. That means 26.6 turns per volt. 26.6 times 18 volts. We don't need more than 18 volts. So we have 478 turns times 2, of course. And for 78, that means like 957 turns with a middle output. Don't forget that, because we need 2 times 18 volts. You see, guys, of course, there are a lot of turns, so we have to do it with the machine. It's easier, but not impossible to do it by hand. I did that so many times, so that's the beginning. It's good to have it kind of stronger. I have to improvise, kind of stand or something. What about this? Can we do something about? Like that? Oh yeah, why not? We go to 0 here, and come on, stay there. Let's start winding. Yep. Okay, 478. We got the first step. So we don't need to put any kind of isolation. I'm just wasting space. Let's go further to 957, okay? Now 957. There we go. That's it, people. Job done. With a machine like this, it takes 10 minutes. Was it 10 minutes? I don't think so. I recommend paper for having this, because better for thermal resistance. Okay, that's it. And to be sure what we have done here, we can even write down the things. 2 times 478, 28. 2 times 18 volts. Well, we'll see about that. As long as we are here, and let's clean these guys, and let's have a little bit of tin. Yeah, that should be enough. Let's get the core back. Of course, this is not final. This is just for keeping the things in place until I found a better case, or maybe reuse this one. Doesn't look too well, I don't like it, but that's the idea of the things. And we need these screws here to keep the core tight and no vibrations. Let's verify the resistances here. The primary, we had like 900 something ohms. Yeah, good to go. What about this secondary? 9.1 ohms. Oh, 46, perfect. And here 23, perfect. So nice. All right, next step, power supply. I mean power, the main power supply. Of course, don't forget safety. This needs to be isolated because it's live power and it's really dangerous. Yeah, it's okay. And power on. Perfectly quiet, no doubt. Do we get any voltage there? Let's see. So 20 volts, alternating current. We have one. Oh, I think it's more than. Okay, we have more. 22.4. Oh man, that's too much. Yeah, but let's not forget that that's in open with no consume here. That's it. Now let's measure. 15.3. Yeah, okay. The point is that I think I've been exaggerating a little bit the number of turns, so I should consider what they've been said before. I mean 266 with 8 volt, so that should be, but no, it's good, it's absolutely okay. So I can tell you 22 volts doesn't hurt the Behringer mixer, but in my case maybe I should open it up and rewind for 400 and maybe 20 or even 400 turns. Okay, one last test to go. Let's see about the amps, how much this guy can deliver. So one of the arms 700 milliamps and 670 milliamps. So we got more than enough current for using this, like Behringer, Phonic, those kind of little mixers, AC power supply. Guys, I hope it's useful. And if you have any question, don't hesitate, write them down. I'll be happy to answer. And for now, that's it. You can use an already done transformer like this one. This one was also modified for 2 times output, you see. Or you can have one from scratch, widening yourself the things. It's kind of difficult without a winding machine, but for secondary, it's possible to be done by hand. 800 turns, it's not a big deal. What else? Don't forget a proper fuse in the primary of the transformer, like 1 amp or something for security. And that's it. Now I can just connect this cable to the transformer, a proper case, and we have a replacement power supply for 2 times 18 volts AC. Thank you for now. Don't forget, subscribe to my channel. Don't forget to write, and of course, have fun. Bye bye.